Hey everybody, welcome to Studio 64. My name's David and I've been searching the interzones for some more science, space and tech news to share with you. And I came across this at Science Alert. Yes, life blossomed when Earth's magnetic field nearly collapsed 590 million years ago. This should be very interesting. And there's the good old magnetic field that we couldn't possibly exist without. Let's have a little bit of a look here and see what they've got to say for themselves. All right, so Earth's magnetic field nearly collapsed some 590 million years ago, presumably putting life on the planet's surface at risk of a rise of cosmic radiation. Now, according to new research, the temporary weakening in the magnetic shielding might have been anything but a biological catastrophe. In fact, it may have boosted oxygen levels, creating prime conditions for early life to blossom. Again, I'm not a scientist. I just love all science. If there's anybody who knows anything more about this subject, please feel free to drop a comment down below the video. I'd love to hear what you think. Earth's magnetic field was in a highly unusual state when macroscopic animals of the Ediacara fauna diversified and thrived. University of Rochester Earth scientist Wen-Tao Huang and colleagues write in their new paper. In 2019, scientists discussing magnetic signatures in rocks from Canada reported that those samples indicated Earth's magnetic field weakened to its lowest known level, about 560 million years old, during the Ediacarian period, where multicellular life was taking shape. However, it was long thought that a vanishingly small magnetic field would be harmful to emerging life because Earth's magnetic field shields life from solar winds. Now, not everyone agreed with that catastrophic view, though. As far back as 1965, planetary scientist Carl Sagan argued that Earth's atmosphere and oceans could have served as a protective blanket for early life forms, even if the planet's magnetic field waned. This was backed up by modelling studies as recent as 2019. But any connection between a coinciding weakness in a magnetic field, boom in Ediacarian life, and rise in oxygen levels has remained, as Huang and colleagues put it, tantalizing but unclear. The Canadian results could be an outlier. So Huang and colleagues went digging. They dug up indigenous rocks from South Africa that formed billions of years ago and studied crystals in them and other 591 million year old rocks previously sampled from Brazil. These crystals contain tiny magnetic minerals, which preserve the intensity of the Earth's magnetic field as they form. Yeah, we don't realise how lucky we are with our magnetic field, and things such as our moon, which, provides us with tides here on Earth. Very, very interesting stuff. Again, I'm not a scientist. I'm just a student of all sciences. I just love them, love it all. As I said, whether it's geology, whether it's astrobiology, whether it's planetary science, marine biology, I don't care. I just love it. Just over 2 billion years ago, smack bang in the middle of the I tell you what, my brain's operating on half of Biden today. Paleoproterozoic period, Earth's magnetic field was strong. Roughly 1.5 billion years later, it dropped to its lowest ebb, about 30 times weaker than it is today, the researchers found. Now, combining their results with those of the 2019 Canadian study, Huang and colleagues conclude that this lowly magnetic field, named the ultra-low time-averaged field intensity, or ULTAFI, lasted for at least 26 million years, from 591 to 565 million years ago. Coincidentally, this interval overlaps with a surge of atmospheric and oceanic oxygen levels around 575 to 565 million years ago during the late Ediacarian, when there was also an explosion in biodiversity. The new data confirming and extending the ULTAFI strengthen a potential linkage with the Ediacarian evolution of macroscopic animals, Wang and his colleagues write. But there was still the question of how an ultra-weak magnetic field could lead to increased oxygen levels. Modelling solar wind evolution, Huang and colleagues suggested the weakened magnetic field may have allowed more hydrogen ions to escape from the Earth's atmosphere into space, which could have resulted in higher oxygen levels in the seas and skies, in turn supporting the diversification of Edicarian life. The timing at the end of the Edicarian, some 540 million years ago, is surprising. Typically, it's the Cambrian explosion that is regarded for its evolutionary outburst, giving rise to complex life that became the animals and insects we see today. I did a video recently. I was just unaware of how solar winds and all this sort of stuff affect our planet. There was also the moon affecting our tides. It also apparently affects our seismology, with the tectonic plates and everything else. That also explains why on Enceladus, the moon Enceladus, gravity pulling it back and forth like that squeezes the planet and then shoots out these massive plumes. I was also unaware the galaxy puts out waves, similar to our sun with its, what was it? Galactic waves will be flowing in, and they would actually, what's the expression? See, I'm not a scientist. This drives me nuts. These galactic waves can actually influence the orbit of planets in our solar system, which I thought was absolutely amazing. It's like the tides on Earth influencing things and things like that. Didn't realize that the galaxy had tidal flows. And again, it's all very interesting stuff to me. I just think it's absolutely amazing. And this, with our magnetic field, having a weakened magnetic field, allowing something to, life to emerge, that, increasing the oxygen levels in the seas and the skies, and allowing different forms of life to flourish, which is really, really interesting. The Edicarian, by contrast, is known for its slimy, squishy creatures that look like primordial sponges, slugs, and sea anemones. It was a period of great evolutionary experimentation that resulted in many dead ends and was marked by steep inclines in biodiversity before life rebounded in the Cambrian. Now, recent research suggests, however, that the first complex ecosystems might have actually formed in the Edicarian, with a 2022 study describing increasingly complex community structures in fossils from the late Edicarian. But life needs oxygen to grow bigger and more complex. Microscopic marine animals and sponges can survive in low oxygen oceans, but larger mobile animals with complex body plans need more oxygen to support their metabolic demands. Yes, a complex animal ecosystem involving long food chains and predators requires still greater amounts of oxygen, as indicated by the exclusion of such complex ecosystems from modern oxygen minimum zones, Huang and colleagues explain. It seems Edicarian life seized on its moment when Earth's magnetic field faded, even if many of those creatures were destined to run into an evolutionary dead end. The study has been published in Communications, Earth and Environment. Very, very interesting, as I say. Obviously not a scientist myself, but I'm fascinated by all science and the links, the cross-discipline things that we witness all the time. So a planetary biologist or geologist, can talk, like an astrophysicist can talk about magnetic fields, at the same time be having a discussion with a paleontologist about how it affected, life and the evolution of life on Earth. And it fascinates me. I've spoken before to many astronomers and astrophysicists about, their conversations that they've had with, planetologists and how how those galactic tides affect the orbits of planets in our solar system. And therefore that would be part of the reason with the gravitational, as I said, with moons like Enceladus, and how that could possibly affect life in the oceans underneath the crust on Enceladus. All very interesting stuff and very exciting. And this magnetic field from Earth, the fact that it actually was diminished during a certain period of time that allowed more oxygen to, in the seas and the atmosphere, enabling life to flourish, is very, very interesting, because everything I see on magnetic fields suggests that the entire planet's going to die. But this is really, really interesting. With those, die with those fluctuations. All right, well, my name is David. Thanks for joining me for another Studio 64 Science, Space and Tech News update. I shall see you in the next one. If you enjoyed this video, please like, share, subscribe. I greatly appreciate it. If you're up for it, drop a comment down below the video because I'd love to hear what you think. All right, take care. And as I always say, if you can't be good at it. And as I also always say,
my brain hurts!